Hey, what's up, guys? This is Cheng here again. So today, today's daily challenge problem, right? Number 554, brick wall. So we have a brick wall in front of us, and the wall is rectangular and has several rows of bricks. So the bricks, each row of bricks have the same length, has the same width, or you can call it, and we need to draw a vertical line from top to bottom, basically across all the rows. And we want to draw a line, a vertical line, in the case that we can cross the least bricks. Okay. And if our line go through the edge between a line of the bricks, then the bricks is not considered as crossed, right? And of course, we cannot draw a line just along on the two sides, on the left or right side, because obviously, that line will not cross any brick, right? So for example, we have example here. We have a brick of wall. The length are given in the list here. We have 1, 2, 2, and there it is, right? So the answer is 2. So why is 2? Because we can draw a line here as just showing right here, right? So if we draw a line here, as you guys can see here, we're only crossing 2 bricks. This 2, then this one. All the others, since the lines are just right in between of those bricks, right? And like I said, we cannot draw a line in here, a vertical line over here, because obviously these two lines will not cross any brick. All right, cool. So and there's some like constraints, right? So the number of rows is like okay. So the number of bricks in each row is in the range of 10,000, and the height of the wall is in the range of 10,000 as well, and the total number of bricks won't exceed 20,000, right? So to solve this problem, we just need to take a look at formula, like come up with a strategy, right? So what are the strategy? Of course, since we're trying to draw a line which will be crossing the least bricks, which means that we of course will be the candidate will be any gap between any any brick, right? Because for example, we have a so how many candidates we have? We have a this is a one of the candidates, right? And then what's the second one? The second one is here. This is this one. We can also draw a line here, and also this is another one, and this is another one. This is the last one, right? So as you guys can see, so one of the approach is that we can simply try, I mean, a brute force way, right? I mean, we can get the total length of the row, right? Total length of the row of each row, and then we simply just try each of the numbers, right? We try each of the numbers from 1 to the max to the last value, and then while we're doing that, we're probably also gonna need like another array to track like the index, like how many like bricks we have been seen for this kind of row, right? Which means at each of the numbers, we have to process each row, right? To be able to track at given the current position as a vertical line, how many bricks we have will be crossing, right? But I think that one is not a very like good solution, because as you guys can see, we have for each of the value here, we have to check each of the row. So a better approach will be what? Okay, so again, right? So we know the all the possible locations are the gap in between, right? So assuming we are at this gap here, if we know like, so at this current gap here, we just need to know like how many rows basically we're not crossing and how many rows we are crossing, right? So for this one, as you guys can see, we're crossing 3 rows, right? I mean, in total, we have 6. The total we know is 6, right? So n is equal to 6. So as we can see that, we're only crossing 3 rows, which means that, there are like the other 3 rows that we're not crossing. So how can we tell from that? Basically, as you guys can see, right? So at this location, the sum is what? Sum is 3, right? Basically, the current sum, right? The current sum is equal to 3, and we have 3 rows that has 3 as the sum, right? So I mean, so this one leads to like a counting solution, or you can think as by using a hash table, which means that, for each of the row, we're accumulating the the length, right? The sum of the length, and we are like adding it into a hash table, and we process it for each of the row. So by the end, so after that, we'll have like a hash table, where the key we'll have hash table. The key is what? The key is the length, right? Is the current sum, and the value is a count. Is a count for this current sum. So in this case, the current sum is 3, and the count is also 3. So which means that, there are like 3 rows that has 3 rows that have the have the gap, right, at this kind of sum here. Because, since all the breaks are positive integers, on each row there can only be at most one count, right? So which means that the number of the count here represents the number of rows that have a gap at the current sum, right? And I mean, as long as we have this kind of hash table or dictionary, right, we can simply pre-populate. Basically, we're counting the gaps. We're counting these gaps at each of the location, right? And then in the end, we're simply traversing the gap, and we're finding the gap that can give us the least cross, or the most count, in another word, right? Because we know the total. Cool. So I mean, with that being said, I'm going to do the coding here. So let's say we have sum count. Okay, it's going to be a default, right, dictionary. I think I misspelled this one, AULT, right? Okay. And for row, right, for row in war, right, for each of the row, we have current sum of this one, and then we have a row length, right, equals the length of the row. Here we do a loop here in range of row length -1. So there's something we need to be careful. We want to stop at at the last one, right? Before the last one. And why is that? Because if we include the last one, so we'll be having a length. We'll be having like a sum equals to the total length for each of the row at the end, right? Because each row has the same length. So if we include the last break, it means that we're gonna have like, in the dictionary, we're gonna have like a sum which equals to the total sum, and the count will always be the total number of rows, which means that, if we do that, the final answer will always be 0, right? That's why we stop before the last one, and then each time we increase the current sum, right, by the current rows brick, and then we increase the sum count dictionary, right, by using the current sum increase by 1. Okay, and now the answer, right? So we have the answer. So the answer is going to be system.max size, right? Since we're getting the minimum. And then for the key and the value, right? So we have a key and then we have the value, right? In the sum dictionary dot items, right? So actually this one, we don't need a key. We can just use like this underscore. All we need is a value, right? Because this at each of the item means that there's a gap at this location, at this position. All we need is the value, because the value is the count. The count for the gaps, right? For the rows that have the gap at the current location. So which means the answer will be the minimum of the answer dot what. So we have an n. Okay, so we need the n here. The n is going to be the length of what, right? That's the total rows. So n minus the value. Or I can use the count actually. So let's just use count. Okay, right? So we simply return the answer in the end. That's it. Yeah, so let's run the code. Count. Uh, 111. Oh, I see. I see. So if there's only one row here, we're not going to have anything in this in this sum count dictionary. So yeah. So I think my mistake. We shouldn't have used this system max as the original value. Original answer. We should use, instead of that, we should use n, right? In this case. Yeah. Yeah, because that's going to be the base point, which means that at the beginning, if there's no like gap at all, right? I mean we can simply use the n as the answer. So submit. Yeah, so this time it passed, right? Cool. So now the time complexity for this one is what? We have a for loop here, right? So it seems like we have nested for loop here, but what we're actually doing here is that we're visiting each brick, right? And since it says the total number of bricks of the wall won't exceed 20,000, so which means that let's say if this one is n, so this nested for loop, the time complexity is O of n, right? And here, so I mean, since we're only this for loop, the dictionary, the size of dictionary will definitely be smaller than this total number of bricks, right? Because there could be some duplicated along the way, right? Because we're like summarizing the count for each of the row. And yeah, so I think that's it for this problem. Oh, and that's why the total time complexity will be O of n, where n is the number total number of the bricks, and the space complexity is, I think it's also O of n, right? I mean, the worst case scenario is that the length of the dictionary will be close to the total number of the bricks. Yeah. Cool. I'll just stop here and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.